Greetings, ladies and gentlemen. We're at the start of a brand new unit, and it's about the features of functions. There's going to be a whole lot of graphs, and you're going to have to figure out what they mean in context and be able to identify some of the properties of the graphs. To actually start off, we're not going to start at the beginning of this little packet. We're actually going to go to the back of that first page to this section. And I want you to actually pause and see if you can match up the graphs on the left with these contextual descriptions, just like what would the graph look like based on if you're baking cookies in an oven and what happens to the temperatures. And so take a moment to pause and do that, and we'll go over in a second. All right, well, let's go through these here. I'm actually going to read the description and then figure out which graph goes with it, because I kind of feel like that would be a little bit easier. So here, first one, the amount of a savings account where the regular deposits and some withdrawals are made. So the deposit means the amount's going to go up, and the withdrawals means it's going to go down. So I want a graph that goes up and down a little bit, something like that. Well, as I look over here, this one's kind of close. It goes up. It doesn't really have down. This one does go up and down. See, this one's just down. This one goes up and it has a little down part there. And this one's mainly just down. Doesn't look like there's a whole lot of ups. And so really it's a battle between these three here. And when I think about putting money into a bank account, you think about, does the money like slowly go in and then slowly come out and slowly go in and out? Or does it kind of just slowly increase and decrease a little bit there? No, that's not how money works. It's not like you go deposit money. Let's say you deposit $100 and then it slowly gets added into the bank account. No, it's pretty instantaneous. It's like, you now have $100 more. Not, you got 1, 2, 3, 4, 5, 6, and it kind of goes up like that. It's usually instantaneous. So this one's actually going to be A here. Next one, the temperature of the oven on a day that mom bakes several batches of cookies. A batch of cookies we put in a pan of cookies. They bake, you take them out, put in another pan. So those are different batches. And when you open the oven, the temperature is going to go down. And then when you close the oven again, the temperature is going to go back up. So the temperature in the oven is going to be going up and down again, a lot similar to our last one. But let's see, is the temperature going to keep steadily increasing, or is it going to kind of have this up and down effect? It's going to be the up and down effect here. B is going to be number 7. And I want to mention that in an oven, it tries to keep it pretty steady, but the temperature is not always the 350 you set it at. It just kind of fluctuates around that temperature. And so this is what you expect to happen. And I want to mention that the temperature doesn't jump in values. It's a smooth transition between the temperatures. We would call this continuous, whereas this one here would be discrete. C, the amount of gasoline on hand at a gas station before a tanker truck delivers more. I don't know if you knew this, but a gas station has tanks of gas underground, and every now and then tanker trucks come in and fill those tanks back up. And so the amount of gas on hand. So you imagine the gas is going to go down until the tanker truck shows up. So we're looking at, let's see, is it going to be down like this one or down like this one? Well, if it was 9, then that'd be like the gas instantly goes into the cars, right? You go to the gas station, you put the hose in, ta-da, you got a full tank. That is not what's happening. The gasoline's not like teleporting into your gas tank. And so it's not going to be 9 because that's just jumping values. It's going to be a smooth deployment of gasoline. So it's going to be 11 there. D, number of watermelon available for sale at the farmer's market on Thursday, or just any day, I guess. Well, again, the number of watermelons available for sale, well, usually they start with a bunch and then it goes down as the day goes on. So really we only have one that's going down. This would be like the available watermelons is going up. So really we just got 9 for D. But I want to mention that this is going to jump in value because it's about the number of watermelons available. And if someone comes in and they buy 3 watermelons, which is kind of a lot, they're going to instantly sell those and so they're no longer available. It's not like throughout the process of selling the watermelon, a certain amount is getting like poured into the person's possession, I guess, and they're paying for it continuously. No, it's like instant transaction. Either those watermelons are for sale or they're not. And so it's going to be instantaneous there. It's got these jumps in values here. It's discrete. And then E, the amount of mileage recorded on the odometer of a delivery truck over time. An odometer just measures how many miles are on the engine. And so that's a steady increase, right? You can move an inch at a time if you really wanted to, but it's not going to like teleport up 100 miles that you've gone. It's a smooth transition, so that's why that one's connected. And the reason I spent so much time on this in this video is because about these sort of things that you notice in real life have a related graph to them. Sometimes things are instantaneous changes, sometimes things are a smooth change, and that's a lot of what this unit's about. Is it going up? Is it going up and down? Is it increasing or decreasing? And that's a lot of different function features that graphs tell you. So the graph can tell you something about a situation, or a situation can tell you about a graph, and they're related to each other. So that's a lot of what this unit's about. And the rest of this packet is really similar to this, but sometimes you're drawing the function or just answering questions about the situation. And so if you flip back to the front, is about you filling in a pool to have a cool pool party, I guess, in the middle of winter, but whatever. And what's going on is you need to draw your own graph of emptying a pool, so it's probably going to go down. You're going to clean it for a while and then fill it back up. But it's not as simple as that. You need to fill in these 6 events here, removing water from the pool a bucket at a time. You can drain the pool with a hose, and then Sylvia and her 2 friends. Oh, sorry, it's not you. It's Sylvia. She's throwing a cool pool party in the middle of winter. And they're using 3 buckets. Well, each of these kind of motions with the water are going to have different ways they look in the graph. For instance, if you're removing water with a bucket, you can imagine let's say here's full. Well, if you put a bucket in the water and you pull it out, that's going to be a pretty sharp decrease in amount of water. But while you're going to go dump out the water somewhere else, the amount of water in the pool is not going to change for a while. So it is going to go down a little bit, but for a while it's not going to be going down. So, and then you can go back and pull out another bucket and then go dump it. And so it's going to be this shift between a drastic decrease and then horizontal for a while because it's not going down in value. And so that's kind of what it will look like with the bucket. Well, not that you need to start with a bucket on your plan. You can choose what order you put these in, but you should probably make sure it goes down first, clean it, and then go back up, because it wouldn't make sense to fill it up, clean it, and then empty it. That's kind of backwards. And if you're instead draining your pool with a hose, that's going to have a more continuous decrease. So maybe you start with the hose, and it's going down, it's going down, it's going down. And then maybe your hose breaks or it clogs up, and you can't use the hose anymore because someone threw leaves in the bottom of the pool and clogged up the hose, whatever. And then you have to use buckets. So for a while you're like, oh no, what are we going to do? And then you realize there's buckets. So you start using a bucket at a time. And then you realize this kind of sucks. And so you Sylvia invites 2 of her friends over. And then they come over and they got 3 buckets. So it's going down 3 times as fast and 3 times as fast. And then you can have it emptied. So you can arrange these events however you want to get the pool emptied, cleaned, and then filled back up. But it does need to go down somehow, be horizontal while you clean, and then filled back up. And so you rearrange it, and then on the next side, you tell the story. Like, what happened? Don't use mine. Use your own story of how those things, those different events came to pass. You can throw in cool details, like maybe Sylvia and her 3 friends are emptying the pool, and then they get into an argument. Sylvia, splashes water on one of them, and it ruins her clothes. And so she runs away in disgust. And so Sylvia's all by herself, and she has to empty the pool with a bucket, whatever. You can create drama if you want. But yeah, you go ahead and you ride out in words, sentences, what story happened there. And on the next part, it's about floating down river. But yeah, you kind of get the idea. There's events going on, and that changes what's going on with the graph, and you say things about it. So it's kind of each one's a little bit different, but you kind of get the idea there. So good luck, have fun.